Hello, way past school people! Chrissy turned in her homework in late, so now we're all blessed with this crummy and extremely rushed animation. Woo! Sonic the Hedgehog, you are way past cruel sometimes. No, what's cruel is that you drew me like this. So, let's begin! So, remind me. What are we doing in this video again? I mean, I know it's important. Smack! We're doing factoring today, Sonic. Thanks, buddy. My head hurts. Well, let's begin with the session. Factoring, a 5-minute tutor. Somewhat. Made by Chrissy, out of the fact that I can't remember to do my homework. So, what's factoring? Okay, so factoring, it's basically when you take a longer equation like x cubed plus 3x squared plus 4x minus 5, and you put it into the simple form. Like, I don't know that one off the top of my head, but it's like if you have, say, x squared minus 4. Factoring, you would have parentheses x minus 2, parentheses x plus 2. And pretty much, it's just the easier way to look and read at it. That's all factoring is. You start learning factoring really in about 7th grade, and I'm all the way in 12th grade, and I'm still doing it. So yeah, I don't know if you're doing it in college, find someone there. But yeah, it's just basic, simple, turning things into a different format. It's easier to look at, nicer to read. The factoring we'll be speaking of will be difference of squares, difference of cubes, and the difference of, no, it's not the difference of, it's the sum of cubes. So pretty much if you don't know your squares and cubes, I suggest you memorize them. That's really the only way to get around it. Okay, so here are your squares. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100, 11 square is 121, and 12 square is 144. For those of you who are wondering how I got these numbers, it's pretty simple. The square of a number is pretty much you take that number and you times it by itself. So 3 times 3 is 9. Also, on your calculator, if you look, you'll see a button that says like x square on it. And you have this crummy mouse doodle of Sonic. Yeah. So on to the next. Okay, so here are your cubes, and for those of you who are wondering how to do cubes, you pretty much take a number and you times it by itself 3 times. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, 10 cubed is 1,000, 11 cubed is 1,331, 12 cubed is 1,728. And you have a doodle of Knuckles, which I drew on my computer with a mouse. Crummy looking, but it's Knuckles. Okay, so here are examples of difference of squares. Here we have x squared minus 4. This one is a perfect squared, but you should also remember this formula. Ax squared plus bx plus c. So if we look at it like a equals 1, b equals 0, because there is no middle number, and c equals 4. With x squared minus 4, we want to put it in a format like this. X plus or minus a number, x plus or minus another number. Some basic rules that we all need to know. The two numbers you used must multiply to get c and add and subtract up to get b. Therefore, there are two numbers that are a factor of c in this case. So our factors of -4 are 1 and 4 and 2 and 2. Now, which ones will add and subtract up to give us 0 for our b? Reminder, 1 must be a negative because, well, it's -4. One's going to have to be a negative. That's kind of your hint. So, and yes, I realized I misspelled must. I wrote much. Can't type much. Ding, ding, ding. Okay, so our answer is 2 and -2. So now, if you put it in factor form, you will get x plus 2 times x minus 2. This is your final answer, and don't forget your parentheses. Some teachers are picky about them, and plus they're kind of needed in order to separate the problem. The whole method and stuff. Okay, so now we're going to make this a little bit tricky. Or don't worry, it's not a little bit tricky. After all teachers will do the same to you later. Here's our problem. N squared minus 2n minus 15. For problems like this, I like to use the big X method because it's simpler for me, and it's kind of like the FOIL method. It puts in a visual for everybody, and which is pretty much what we did earlier. We did FOIL. There's also a random Punnett square looking thing. I went to school in Atlanta for a year, my freshman year, and that's kind of what they did, but they didn't really teach it to me because it was apparently taught to them in middle school. So I don't know anything about that little Punnett square. I'm sorry, I can't help you there. I can help you with this big X method. And for those of you who are wondering how it works, if you look, I drew this big X with my mouse, and if you remember our formula, ax squared plus blah blah blah. Okay, so our formula is ax squared plus bx plus c. And as you can see here by our wonderful little X drawn, in the first one we're going to have a times c in that little top portion. In the very bottom we're going to have b. In the two sides we're going to have our two numbers, which will later be put in our parentheses. However, we're going to divide those numbers by a. A lot of teachers tend to forget to tell students and others to divide those two numbers by a. It's really helpful for in a later problem, which I will show you, where you have like a number like say 25 in front of for your a instead of 1. It's helpful. Don't worry. It's not going to be too scary at all. It shouldn't be. You'll understand. So let's get on with the problem. Yeah. Okay, so here's our basic work. Our a is 1, our b is -2, and our c is -15. So up top we did times 1 by -15, and we get 15, and we put -2 in our bottom unit. So now what we have to do is we have to find our factors of -15. Our factors are 1 and 15 and 3 and 5. 3 and 5 will multiply to get -15 and add up to get -2. And so you put 3 and -5 in the little side spaces, and then you divide them by 1. 3 divided by 1 is just 3, and -5 divided by 1 is -5. So in our parentheses, we're going to have n minus 5, parentheses again, n plus 3, parentheses. And that's pretty much just it. It's really simple. Not very hard. Okay, so now we're going to start on the difference in sums of cubes. Here's your formula. A, same sign as the original. B, parentheses again, a squared, opposite sign as the one you used before. AB, and then always positive, b squared, and parentheses. This formula is the same no matter which one you're doing, whether you're doing difference or sums of cubes. It will always be the same. If you have something like a minus b, like a cubed minus b cubed, you will have a minus b, parentheses, a squared plus ab plus b squared. Or if you have a cubed plus b cubed, you'll have a plus b, then you'll have a squared minus minus ab plus b squared. It's just that simple. It's not that hard at all. You'll pick it up really quick. Okay, so here's our example. 125x cubed plus 1. So using our formula, I feel I should note, you want to take the cubed root of all the numbers. I didn't do that at first, but now I know, and now I'm telling you so you all know. So we should get 5x plus 1, parentheses, 25x squared minus 5x plus 1. Notice your original formula said same, opposite, and always positive, and that's exactly what we did here. And look, little doodle of Tails' head. Very creepy looking. I should stop drawing with my mouse. Okay, so here's our next example. 64n cubed minus 4. The cubed root of 64 is 4, and the cubed root of 4 is 2. So if we follow our formula, we'll get 4n minus 2, parentheses, 16n squared plus 8n plus 4. It's n in parentheses. So it really is very easy as long as you follow the formula, and the formula isn't that hard. It's a lot easier than, say, your formulas for your special triangles and all that stuff. It's really simple. Okay, so I want you to note that the order in which your x, y, b, t, or z does not matter. Like, whichever little letter you have, it doesn't matter. You could have a problem like, say, 1 minus 27x cubed. You do not render them at all. You do not reorder them. I'm sorry, I can't even read my own typing. You don't want to reorder them at all. Your a is 1 and your b is 27. Well, your b is cubed root of 27, which is 3. I apparently can't type. So you just plug in all these numbers into your formula. So you get parentheses 1 minus 3x, parentheses, and then parentheses again, 1 plus 3x plus 9x squared. I forgot the x in that first one. It should be 1 minus 3x. I will stress that again. I apparently can't type and don't pay enough attention to these notes when I type them. Sorry. I will correct it maybe. I'm too lazy. I'm sorry. Too lazy. Yeah. Okay, so this seems to be my last page of notes. Wow. So I hope you enjoyed factoring a 5-minute tutorial. It's not really 5 minutes, is it? It's like more like 13 some. This is what happens when I forget to do my homework. I'm thinking I may want to make more of these if anyone's interested in watching them. I don't know if it's helpful for any of you. Comment below. I probably missed some. I'm too lazy to add other problems, but you can find practice problems online. Just type them in, or you can ask your teacher for them. If you're not doing factoring, or if I did any factoring wrong, tell me. I'm not very good at factoring. I'm good at it, but either way, you're going to be doing this for like ever. Forever. It's tiring. So I hope you all enjoyed it. Me and my math 4. So if you want any more videos like teaching you stuff, not necessarily math, but things like I'm good at literature and English. I could teach you about nouns or something. I don't know. I'm just rambling. Do 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 do.